This video is brought to you by PCBGOGO.
My new apartment has no mad science decoration in it. There's nothing here that has any plasma, no fire, no lightning. We need to change that. We need to do something that's never been done before, something that's simple, cheap, easy to do, really uses the engineering design process, and something that makes my room pop and says, wow, he likes electromagnetism. So let's build something pretty cool, and yeah, that's my problem. It's boring in here. So in order to achieve those goals, I want to use the engineering design process. Identify, research, imagine, plan, create, test, improve. So let's start with step number 1, identifying the problem. See, my problem is pretty complex. It's that it's boring in here. Now we move on to step 1B, the constraints. The constraints are that I want this Jacob's ladder to be powered off 120 volts AC and a max current of 20 amps. That's the power that can be provided to me by my wall. I also want the Jacob's ladder to be non-lethal, 6 feet tall, less than $200 cost, original aesthetic, easy to build, able to run for a reasonable amount of time without overheating, and also controllable by my smartphone. So that's a tall list of orders, but I know that with the engineering design process, we can make it happen. So now let's research our problem. I want to make a 6 foot tall Jacob's ladder. Has anybody done it before? This is pretty straightforward. And then here are our results. There are 2 main designs I've found. And by designs, I mean designs for the power supply. Here we have Coil Labs. He's using microwave oven transformers in a resonant circuit to provide a large spark with a relatively small amount of components. Here we have Tesla Coil Pro's Jacob's ladder. It's gigantic, huge sparks. The driver is a little complicated and it's more expensive than the microwave oven circuit. So now step 3, imagining possible solutions. It looks like our possible solutions for a power supply is the microwave oven transformers or a flyback driver, as they call it. All right, we imagined it. Step 4, planning. I've combined the pros and cons into this table right here, and honestly, because I can get the microwave oven components for cheaper, we're gonna go with that one. My final plan looks like this. It is a spiral Jacob's ladder that adds the uniqueness to it. I think that'll add an awesome 3D element to the spark. Also, I've integrated a remote turn-on feature with a high voltage DC module that I can send a signal to from my phone using a custom PCB in order to turn on the Jacob's ladder when I want to. I'm modeling my circuit off of this one right here, which uses 2 microwave oven transformers, but I'm just going to use 1. I want to have as minimal components as I can, and then you have a power factor correction capacitor, which will offset the inductive reactance that the transformer has. And if you don't know what that means, look into power factor correction on YouTube videos. And now comes the easiest part, which is building it. I also need to figure out how I'm gonna lay out the circuit in 3-dimensional space. Prioritizing symmetry and minimal wires is how I came up with this design.
Here's a 3D model of what I'd like it to look like. And now this is what all the pieces are. So let's start getting the materials.
Oh wait, what the?
It's right.
7 amps.
Okay, here we go. 3, 2, 1. Oh. Did I do this right? I think I know what happened. Yeah, I think I know what happened. So I figured out that I needed to attach a copper wire to the body of the transformer in order to see the big resonant arcs. Now I've added a power factor correction capacitor, which is 31 microfarads from an old sodium lamp, and it's pulling 6 amps with no arcs, and you get the same result. So this is what our Jacob's ladder is going to be powered off of.
There is actually another issue that we have to address with the power supply, and that's that I don't know how big of an arc the power supply will be able to sustain. So I need to make a little Jacob's ladder prototype and test my power supply on it. So let's do that.
Okay, here's the setup. All right. Oh, I thought that might happen. It's shorted underneath this. So this setup is not going to work. Watch. All right, there we go. The sturdy Jacob's ladder setup. Let's go home and set this up. All right, our high voltage generator is here, so let's see if it works. Yep, that works. Great. Damn. So not enough to break the air down as I thought it would be. Ah, it worked. All right, so after tonight's experimentation, my favorite setup is this one. A 4 centimeter gap between the copper electrodes, you could call them, and the orientation of the igniter is above and below each other, and that allows the arc to ignite and then also rise. But if you don't have a difference in elevation between the electrodes of the igniter, I find it hard to get it to ignite. So watch this. Pretty reliable too. Then sometimes that happens. And it pulls about 17 to 18 amps. So that's 2,280 watts of power. It's like 2 microwaves running at the same time. Yeah.
So in order to protect the audience from the art piece, we need to put up a shield because my power supply is lethal. Let's see, we could do a glass shield, we could do a plastic shield, or we could do a metal shield. A metal shield would block our view of it, so that's off the list. A glass shield could work, but it would be really heavy and expensive, and yeah, no. So we're gonna use a plastic shield. I called a plastics company, and they said that a giant acrylic hollow cylinder would cost like $1,000 or something. That's out of the budget. So I moved on to the next possible solution, and that is a square acrylic protective case. If we use 4 individual panels of acrylic that are 6 feet tall and we glue them together, that should be in my budget. Yesterday I submitted an order to SoCal Plastics Pro, and I just got the call from them. They finished slicing the acrylic, and I'm gonna go pick it up right now. Thank you, man.
You're welcome, man. All right.
But as you can imagine, we needed a way to combine the acrylic sheets together into a rectangular prism sort of shape. So I'm just gonna use acrylic cement and glue the thin sides to each other, and check out the setup I used.
There we go, ladies and gentlemen. The acrylic box attachment. Okay, I think we're good. Now we just let it sit for 2 days and see the structural integrity. So here we have the enclosure. so that no one will die when they get near it. So now let's go pick up the piece of PVC plastic that I had machined so it has a square groove in it so that this thing can fit into a base, and I think this is the best way to do it. So let's see if the machined part was machined well. So let's go. Okay. Okay. Here is the base plate that the machine shop machined for me. So let's try to fit the plastic housing into it. Oh wait, I might just have the wrong sides. I'll just rotate it.
Oh, probably, yeah.
Yeah, right, because it's like, oh, this should work. Oh, that's, oh,
Seems close.
that looks like we got it in. It's just the, all right. This is Hector, who helped me out at Herrera Machine Shop. So shout out to Herrera Machine Shop for helping me make this project possible and making the base plate for me.
Yeah, no problem. Can't wait to see the final product.
Now we just got to mount the circuit on it, put some wheels on the bottom.
So now the question is, what circuit are we going to use to activate the Jacob's ladder using my phone? Well, just like in my plasma toroid video, if I get a cheap Bluetooth module from Amazon that can connect to my phone and send electrical signals to a switch on the Jacob's ladder side. But here's the thing, the cheap Bluetooth module that I bought from Amazon doesn't have enough power to output a signal that can turn on the high voltage DC module. So we need an amplification stage. And for that, I'm going to use this simple circuit. First, I need to prototype this circuit, and that included all of this, and a little bit of this, and a little bit of that. And so I knew exactly what I needed for this project. Instead of a jumbled wire mess like that prototyping board, we can use a professional printed circuit board. So that's right, this video is sponsored by PCBGOGO.
PCBGOGO is a reliable and high-quality PCB manufacturing and assembly company. Here is their PCB assembly page, and you can put in what components you need and your design, and they will assemble your PCB for you. You can also take a look at their manufacturing calculator, and here you can choose the materials you want. You can upload your Gerber file, which is the file of your PCB that has all the information. You click that, upload it, and here it is. We get an estimation of the price. It says $29, but really, with a special offer they're offering right now, you get a $25 PCB order for just $1 and free shipping if you live in the US or Europe. So it shouldn't say $29, it should actually say $1. And you get shipping in about 5 days. So $1 PCB in 5 days. Sounds pretty good to me. So look down in the description below for the promotion link so you can get this offer. Okay, here we go. First test. Turning on main switch to run everything. Bluetooth receiver board not being powered up. The Bluetooth module light is not coming on, so it's not powered on. It's only at 3.5 volts, but we need it at 5 volts. Dang. I think this is a load issue.
Too many things are connected to the transformer. Okay, I've just replaced the full bridge rectifier with a half wave rectifier, and now we're going to power it on, and hopefully we're looking for a blinking blue light over here, and that's how we know we're good to go and move on. Dang. Nope. Here's the voltage supplied to the Bluetooth module, and it needs to be at least 3.7 volts. So the capacitor is just not big enough. I can increase its size, but at the max, it charges up to 3.64, so might not even be worth it. Test 2, a 15 times larger capacitor right here. And let's switch it on and see if our blue light glows. No! Damn. Well, I know that the transformer's running, so I might as well see if our Jacob's ladder will even work. Oh. Huh. That's better. Oh. It's highly unstable. So I took the sculpture home and I came up with a new design for the Bluetooth receiver circuit.
5-volt regulator circuit powered off a 9-volt battery, which I can switch on and off from outside the box with this switch. There we go. Bluetooth powered up.
Okay, here we have our setup. It's totally working, but the arc seems to be not hot enough, maybe. In 3, 2, 1. Oh, it's not paired to the Bluetooth. Bruh. There we go. Let's try again. 3, 2, 1. Ooh. Yeah, but then it resets the Bluetooth, so. Yeah, that's definitely an issue. Okay, ready.
Okay, nobody.
Resumes all the way out?
Yeah.
Okay, cool. Here we go.
Here now this one.
Interesting. Very interesting.
What happened, Double T?
Well, it went the wrong way. It went downwards.
So with the Bluetooth igniter still not working how I wanted it to, I refined the spiral Jacob's ladder shape a little bit more and ignited it with the stick again. Maybe I'd learn something and we'd get some sort of success.
Alright, let's see if this distance and shape works well. See, the magnetic force over here pushes out the plasma because the coils are so close together, and it doesn't go all the way up from down there. It just stops. Yep. Ooh. I think this is our shape. Yeah.
Okay, I've been trying to get this thing to ignite for 2 weeks now. The high voltage DC module just popped on me, and I don't know what else to try with this circuit. So I'm gonna need your guys' help. Put a comment down below and suggest what do you guys think I should use to ignite this thing. The engineering design process has not failed us yet. We're just going back to the design phase. If I've learned anything about science YouTube, it's that YouTube can teach you anything, and that you guys are really smart. I learned everything I know about electrical engineering from YouTube. So let's do this, guys. Like, do I use a ZVS driver now? Do I use a electric candle to ignite the bottom? Like, put a comment below and let's do this thing. But I'm at my wit's end here, so that's all I got for you guys today. And just to make it clear, the PCB that I ordered from PCBGOGO works fine. It's just the high voltage DC module on the other side that doesn't work. So thanks everybody for coming along for the ride, and I'll see you guys in the second part of the video.
Now I'd like to personally thank all of my patrons right now, and they are Colleen, Lauren Halpert, Jonathan Selstad, Eric Weiss, Kirill Glazkov, Zachariah Campbell, Codex, Austin Dale, Sung Ju-yi, Dion Petrick, Hudson Cooper, Gewison, and Jesse Brockman. Thank you.
All right.
All right.
So what's happening?
Okay, so what's happening is